Good morning all. In today's class, we will discuss inter-thread communication, okay, which is there in multi-threading. Okay, today I will complete inter-thread communication, thread group and daemon threads. So with these three topics, we can complete this multi-threading. Now coming to inter-thread communication, it is very, very important for final exam point of view also. Okay. Two threads can communicate with each other by using wait, notify, and notify all methods. So here we in inter-thread communication, we will discuss three methods. Okay, they are wait is one method, next notify is the second method, and notify all is the third method. So with these three methods, that is wait, notify, and notify all, we will discuss inter-thread communication. So here two threads are communicating with each other by using wait, notify, and notify all methods. Okay. So wait, notify all methods are available in which class? Methods means they must be available in one class now. So previously we have seen so many methods. What are the previous methods in multi-threading? We have seen sleep method, yield method, okay, interrupt method, join method. Okay, we have seen so many methods till now in multi-threading, but all those methods are there in thread class. Thread is a predefined class. So all the previous methods are available in the predefined class thread. But here, if you see the difference, so here wait, notify, and notify all, these three methods are available in which class? Object class. That is the difference we have to understand here. Okay, previous methods are there in the thread class, but wait, notify, and notify all methods are there in the object class. You know, every class in Java extends object class. Okay, that's why all these are in wait and notify all methods are there in the object class. That's why every class in Java extends object class. That's why, okay, wait, notify, and notify all methods are available for each and every class. Why? Because all the classes are child classes of object class. That's why here we have wait, notify, and notify all methods are there in the object class. That's why in Java every class extends object class. That's why every class in Java can access wait, notify, and notify all methods because of inheritance. Okay, directly you can access wait, notify, and notify all methods in your class because every class in Java extends object class. This is one more important point to remember. With respect to these three methods, they are wait, notify, and notify all. Okay. Next, to call wait, notify, and notify all methods, compulsory the current thread should be owner of that object. Okay, so it has to acquire the lock. And one more important point is, this is important point, current thread should be in the synchronized area. Last class I explained synchronization. Synchronization means methods can be synchronized and blocks can be synchronized. Means we can write synchronized methods as well as synchronized blocks. Already I explained the programs on synchronized methods and synchronized blocks. Only in the synchronized area, remember this point, very, very important point. Only in synchronized area, we can use these three methods. That is wait, notify, and notify all. Methods must be used. Okay, in which area? Synchronized area. Synchronized area is nothing but synchronized methods or synchronized blocks. This is the one more important point. Okay, so to invoke, or we can invoke, okay, wait, notify, and notify all methods only from synchronized area. That is either from the synchronized methods or synchronized blocks. Next. Here, hence we can call wait, notify, and notify all methods only from the synchronized area. Otherwise, okay, if you access these three methods from non-synchronized area, then what do we get is, we will get runtime exception, saying the exception name is illegal monitor state exception. So this is very, very important. So these three methods can be called or invoked only from the synchronized area. That is either from the synchronized methods or from the synchronized blocks. But we can't invoke these three methods from non-synchronized area. If you access these three methods from non-synchronized area, definitely you will get runtime exception, that is illegal monitor state exception. So all these are very, very important points. If you understand the theory, programs are very, very easy only. Next, once a thread calls the wait method, now we will see what are the roles of wait, notify and notify all methods. Okay. Next, once a thread invokes wait method, okay, it immediately releases the lock of that object and enter it into the waiting state. This is important. So between two threads, we are discussing inter-thread communication. So let us take, this is the first thread. Okay, suppose if the first thread calls the wait method, then what will happen? Then it immediately releases the lock of that object and enter it into the waiting state. This is the role of wait method. Again, I will explain this one. Let us take two threads, because between two threads only we can explain inter-thread communication. Okay, two threads are communicating. In the first statement itself, I told, two threads are communicating using the methods wait, notify and notify all. So let us take two threads, thread 1 and thread 2. Let us take, this step 4 is for thread 1. Suppose the first thread 1, okay, calls or invokes the wait method. Then it immediately releases the lock. This is important. It immediately releases the lock of that object and enter it into the waiting state. Because with respect to synchronization only, we are discussing wait, notify and notify all method. Now, synchronization is nothing but synchronization methods or synchronized blocks means the thread has to acquire the lock of that object. Then only it can access the synchronized methods or blocks. That's why once a thread invokes wait method or the first thread invokes the wait method, then it immediately releases the lock of that object. Releases important, because we are concentrating on only synchronization in inter-thread communication. Synchronization is nothing but with respect to lock concept only we have to discuss. Last class I explained object level lock, class level lock. Class level lock means static synchronization. Object level lock means synchronization. Okay. Now, once the first thread invokes the wait method, it immediately releases the lock of that object and enter it into the waiting state. Releases the lock of the object and enter it into the waiting state. Next, this is wait method. Next, once a thread gave the notification call, this is the second thread. Because the first thread is releasing the lock of the object and enters into the waiting state. No, then at that time the second thread acquires the lock of that object, because the first thread releases the lock of the object and entered into the waiting state. No, at that time the second thread acquires the lock of that object. Okay, after completion of that method, what the second thread will do is, once the second thread gave the notification call by using notify or notify all, then the thread releases the lock of that object. Means here also the second thread also releasing the lock, because the second thread acquired the lock of this object after releasing the lock by the first object. No, so when the second thread acquires the lock of the object, so after completion of that method, what the second thread will do? The second thread will call or will invoke either notify or notify all method. So what does it mean? Means, so it is informing to the first thread, saying that I have completed my task, then you can take the lock of that object. Like that, using this notify, it is given, second thread is giving information to the first thread, because first thread is in waiting state. No, okay, so here the second thread is giving the information by using the method notify or notify all to the first thread. Okay, that is the concept of notify. And first thread will use wait method and immediately releases the lock and enter it into the waiting state. Next, second thread acquires the lock of that object and it completes its execution. After that, it will give the notification call to the first thread, because first thread is in the waiting state. No, so when the second thread gives the either notify or notify all method, then it is informing to the second thread is informing to the first thread, saying that I have released the lock, you can acquire that lock. So these two are very, very important. Wait is only on the first thread, and notify all is on the second thread. If you understand this wait method and notify all, programs are very, very easy only. So only first method, on the first thread we apply wait method, on the second thread we will apply notify or notify all. Okay, these two are very, very important. So again I am repeating, the first thread, okay, invokes wait method. Then what it will do, it immediately releases the lock of that object and enter it into the waiting state. So when the first thread entered into the waiting state, now the second thread acquires the lock of this object, same object. The second thread acquires the lock of the same object and completes the execution of that particular method. After completion of that execution of that particular method, it will invoke notify or notify all. Means what is the meaning of this notify on the second thread is, it is giving information to the first thread saying that I have completed my work and I am releasing the lock of that object. You can take the lock of the object, because the first thread is in the waiting state. No, that's why second thread is giving the information to the first thread which is in the waiting state. Then at that time the first thread can acquire the lock. So these two are important. Okay. Next, here the second thread also releases the lock of that object, but may not be immediately. Okay, so these two statements are very, very important. Only first thread wait, second thread notify or notify all. Next, except wait, notify all. Okay, except the methods notify all methods, there is no other method, okay, where the thread releases the lock. Only in these three methods, in these three cases, the thread is releasing the lock of that particular object. Okay, that is the sixth point. Here also in wait method, here I am using releases the lock of the object. No, in notify and notify all also, we are using thread releases the lock of that object. That's why only in these three cases, that is wait, notify and notify all, in these three methods we are using the thread releases the lock of that object. Okay, that's why sixth statement is that only. Okay, if you see previous methods, yield, join, sleep, here the thread is not releasing the lock. No, see, for these methods synchronization is not required. Okay, non-synchronized methods enough, but to apply wait, notify and notify all, synchronization is must. Synchronization means lock of the object is must. So with respect to the lock of the object only, we will discuss wait, notify and notify all. That's why only in these three cases we will discuss lock of the object, and we will discuss releases the lock of the object. Okay, so in these three cases only we will discuss the releases lock of the object. So here is the thread releases the lock. So in which methods is, okay, the thread releases the lock. So yield method no, join method no, sleep method no, because these three methods are applied on non-synchronized methods, means non-synchronized area. But these three methods are applied on synchronized methods or synchronized blocks. That's why lock of the object comes into picture. That's why when you use these three methods, we have to discuss with this concept, releases lock. That's why thread releases lock in case of wait method S, in case of notify method S, in case of notify all method S. So this table is important. Next, a thread can acquire multiple locks at a time, but whenever we call wait, notify or notify all, thread releases the lock of that particular object, but not all locks it has. This is important. Only on the particular object we are invoking this wait method. No, only it releases the lock of that particular object. Okay. Next, now you can see all these Now we will see the method signatures for these three methods. Okay. If you see weight method, there are weight method is a overloaded method because it has three forms. In the first form, it is a final method, no return type, and weight. It is not taking any argument or parameter. Throws interrupted exception. Next, wait long millisecond, throws interrupted exception. Wait long millisecond into nanoseconds, throws interrupted exception. These are the three forms of wait method. That's why wait method of the object class is overloaded method because it has three forms. You know overloaded methods and overloaded constructors, no? So wait method is there in the object class, which is overloaded method. If you see the sleep method of thread class, see same syntax. Sleep method also throws interrupted exception and okay, the milliseconds, nanoseconds. Only in place of wait, if you put sleep, same, but only difference between wait method and sleep method is sleep method is there in the thread class and wait method is there in the object class. That is the difference between sleep method and wait method, but syntax wise both are same. Both are throwing interrupted exception. When wait method is throwing interrupted exception means the invoking method or the calling method of this wait method must be either handled or declared this exception. Handled means the calling method must use either try catch blocks or the calling method must throw interrupted exception, use throws keyword or using throws keyword. Okay, already you know. Interrupted exception is a checked exception. So checked exceptions must be either handled or declared. That's why the calling method of the wait method must use either try catch blocks or the calling method of the wait method must use throws interrupted exception. Compulsory either or, either handling or declaring. Okay. So this is very important. Throws interrupted exception means interrupted exception is a checked exception which must be either handled or declared by the calling method of this wait method. Okay. When you see the program, you can understand. Whenever you write wait method, compulsory there should be either try catch blocks for wait method or the calling method must use throws interrupted exception. Okay, understand wait method like sleep method only. Next, notify. Notify means no org. Notify also no org. For notify, I think two are there. It is also overloaded method. One is this one. Second one is time also there, milliseconds. So notify is also overloaded method. It is not given here. I have shared two. I am sharing two materials. In the second material, you can find. Okay, notify all. Time also there. Okay. Next. So all these are final methods. Means in the subclasses we can't override these methods. Next. So this is the diagram for wait, notify and notify all. So for all the concepts, whether you take yield method, this diagram is must. Or if you take sleep method, diagram is must. Or if you take interrupt method, diagram. Or if you take join method, diagram. Like that, for wait, yield, for wait, notify and notify all also, this diagram is must. Explain wait, notify and notify all methods of the object class. Means first draw the diagram. With respect to the diagram, explain the points. With respect to wait, notify and notify all. Shall we see this diagram is same. This is what? You know the first diagram is this, no? Four states. You are born, ready or runnable, running, dead. Okay, I am taking the same diagram, that is the life cycle of the thread. Using the life cycle of the thread diagram, I am extending, okay, based on the method. Here it is wait, notify all. No? So for first thread is in the running state. If you remember here, this is with respect to two threads. So we assume that first thread is in the running state. So when the first thread is in the running state, so on the first thread, if you invoke wait method, then what the first thread will do? So first thread will go to the waiting state. Okay, up to this, okay. Okay, when the first thread is in the running state, so on the first thread, if you invoke wait method, then the first thread will go from the running state to the waiting state. This is first thread. Okay. After that, now the second thread acquires the lock of, because when it goes to when the first thread goes from the running state to the waiting state, the first thread releases the lock of the object. So the first thread releases the lock of the object. Okay, and it enters into the waiting state. After that, now the second thread acquires the lock of the object and it will be entered into the running state. Now, after completion of the execution of that method or block, okay, what the second thread will do is, the second thread will invoke notify all methods. Okay, the second thread will invoke either notify or notify all methods. Then at that time, okay, the second thread is also releasing the lock of the object. And what is the meaning of this notify or notify all methods which are invoked by the second thread is, when the second thread invokes the notify or notify all methods means it is informing to the first thread saying that I have completed my task and I have released the lock of that object. You can take the lock, you can acquire the lock of that object. So the second thread is informing to the first thread. First thread is in the waiting state. Okay, using the notify or notify all. Then at that time, what the first thread will do is, the first thread will go to the blocked state to get lock. So when from the waiting state, the first thread will go to the blocked state to get lock. When the first thread will go to the blocked state from waiting state is, these are the three cases. If waiting thread got notification, this is the waiting thread, the first thread is in the waiting state means first thread is the waiting thread. If the first thread is, or if the first thread got notification by the first thread using the notify or notify all methods, then at that time from waiting state it will go to the blocked state. The first thread will go to blocked state or time expires, because wait method we are using time, no? Or if the waiting thread got interrupted, already explained this interrupted method. The waiting thread got interrupted by interrupt method. Okay, so in these three cases, the first thread go to this blocked state from waiting state. Okay, next after that, from blocked state, when it will go to the ready state means if the waiting thread got the lock, because already we studied, whenever the second thread releases the lock, whenever the second thread uses the notify or notify all methods, it may not release the lock immediately. Already I explained previously. So it may not, the second thread may not release the lock immediately. So whenever the second thread releases the lock, at that time only the first thread will go to ready state from blocked state. So whenever the first thread acquires the lock, okay, from the second thread, at that time only it will enter into the ready state from blocked state. Now first thread is in the ready state, again it can go to the running state and it can acquire the lock of that object. So it is between two threads we have to explain. Next, once you understand this programs easy only. There are two programs in this material, one program, and in another material one program is there. So try to practice these two programs on inter-thread communication. Already in your lab syllabus you have one program, that is producer consumer problem. That program also comes under inter-thread communication. So in that producer consumer problem also we use wait, notify and notify all methods. Okay, you can write any program in the exam. At least try to remember one program on inter-thread communication. So here this is the program class. This is the program on inter-thread communication. You have to take two threads. Okay. Now class thread here. This is the class name. Public static void main throws interrupted exception, because we are using wait method inside the wait method we are using inside the main method. Means wait method is throwing the interrupted exception. So the calling method, who is calling wait method? Main method. So main method is the calling method of this wait method. That's why either main method must handle the exception, that is interrupted exception. Suppose if main method wants to handle that exception, what the main method will do is, for wait method it will put try block and it will write the matching catch block, that is for interrupted exception. So to put the wait method in the try block and write the corresponding matching catch block. Okay, that is one way. Or in the calling method can use throws interrupted exception. Both are correct because interrupted exception is a checked exception. So for wait method, some people they have taken throws interrupted exception. So throws interrupted exception means wait method throws interrupted exception means interrupted exception is a checked exception which must be either handled or declared. Otherwise, you will get compiler error. Checked exceptions are checked by the compiler during the compilation time. That's why they are very, very dangerous. Unless you handle or declare, or unless the calling method, main method, okay, either handle means use try catch blocks for this wait method, or it can use throws interrupted exception. That's why here in this program we have used this calling method. Main method is the calling method of wait method. That's why main method uses throws interrupted exception. Otherwise, main method can use try catch blocks. That is nothing but handling the exception. This is nothing but declaring the exception. So checked exceptions must be either declared using try catch blocks, must be handled by using either try catch blocks, or declared using throws interrupted exception. That is must, either handled or declared. Okay, because main method is calling wait method. That's why main method must do either handling or declaring. For sleep method also same concept. Whenever you use sleep method, again we have to do same. Either use try catch blocks for sleep method or use throws interrupted exception. Okay, understand carefully. You know in this exception handling, no? Now I will complete fast. Class thread A, public static void main string args, throws interrupted exception. Thread B means I am using one more thread here because with respect to two threads only I have to explain inter-thread communication. No? So this is the second thread. Main is the first thread. See here, main is the first thread. What is the second thread? Second thread is this one. This class is nothing but second thread. You know how do we identify whether it is a thread or not? Is any class which extends either thread class or either which implements runnable interface means that is thread. First, shall we see the thread class? So class thread B extends thread into total is equal to 0 public void run method. We must override the run method now inside this thread class. So this is the overriding run method. Here we are using synchronized of this. You know, I already explained synchronized block. Synchronized block means inside non-synchronized method. Run is a non-synchronized method. That's why inside the non-synchronized method, I am using synchronized block. Only some part of this run method, only for some part of this run method, I am using synchronized block. What is that one? Synchronized of this. This means current class object. So synchronized of this up to this. Okay. So this is some part of this run method. But here we have not written any other statements. But if you want to write any other statements inside the run method, you can write it. Because non-synchronized method. Run method is non-synchronized method. Inside that I have taken some part as synchronized block. Okay, this we can write this program for synchronized blocks also. Explain synchronized block in multi-threading means we can write. So synchronized of this system.out.println child thread starts calculation for int I is equal to 0. This is the role of child thread. Okay, it is calculating total value by repeating this for loop 100 times. Next system.out.println child thread try to give notification. This is second thread, remember. Main thread is the first thread. This is the second thread. Always already explained. First thread must use wait method, and second thread must use either notify or notify all methods. Okay. Now this is the second thread. That's why inside the second thread I am using this dot notify. See, second thread is using notify. Now child thread try to give notification, or child thread is giving notification call using this dot notify. So here what we can understand is always second thread must use notify or notify all. Here this is the second thread. Where is the first thread? This is the first thread. You know, main is the one thread, no? So inside the main thread, I am creating the object for the thread class, that is thread B. B is equal to new thread B dot start. So from this, we have, you know, normal multi-threading only. From after B dot start, we have two threads, that is main thread and child thread. I am taking main thread as the first thread and child thread as the second thread. And inside the main thread, this is main thread too. So inside the main thread, this is the functionality of main thread. Okay, inside the overriding run method, this is overriding run method. Inside the overriding run method, I am writing the functionality of the second thread. Okay, inside the overriding run method, I am using the synchronized block to write the functionality of the second thread. But inside the main thread, using the synchronized block, this is also synchronized block, we are writing the functionality of the main thread. Only inside the main thread, I am using wait method. That's why take main method as the first thread and second thread is my thread B. Now inside the synchronized block of main thread, what I am writing is, this is the synchronized block. System.out.println main thread calling wait method and B dot wait. So here I am invoking B dot wait. B is this one, B dot start. Here this is the thread, this one, synchronized block. I am writing B dot wait. So system.out.println main thread got notification. System.out.println B dot total. This is the program. Try to understand. In main thread, I am using synchronized block, and in the overriding run method also I am using synchronized block, and in the main thread I am using B dot wait method. Wait method I am using inside the main thread. That's why consider this main thread as the first thread, and inside the second thread or inside the synchronized block I am using what? Notify, means treat this as the second thread. So first thread uses wait method and second thread uses the notify or notify all methods. And one more important point here we have to see is always wait method or notify all methods must be written in the synchronized area only. Already in the previous statements I explained. Wait method, notify method and notify all methods must be invoked from the synchronized area only. It can be either synchronized block or synchronized method. But in this program, I am using synchronized block. Inside the synchronized block, I am invoking the wait method on the first thread. Next, on the second thread also, inside the synchronized block, I am using notify method. So now try to understand wait and notify methods must be invoked from the synchronized block or synchronized method. This is synchronized block. This is opening brace of the synchronized block and this is the closing brace of the synchronized block. Inside the synchronized block only, I am using notify method. This is must. Otherwise, you will get error only. If you use directly this notify method from inside this non-synchronized method, then you will get runtime exception. Okay, that's why I have used notify method here inside synchronized block, not inside non-synchronized run method. You can't use notify method inside non-synchronized run method, but inside synchronized block or inside synchronized method, I can invoke notify method. Similarly, in the same way, see, if you see wait method also, we are invoking the wait method also inside the synchronized block only. This is synchronized block because synchronized block syntax is this one. Now this is synchronized block. Inside the synchronized block, I am using b dot wait. And now try to understand. Here we have two threads. One is main thread and another one is child thread. Main thread is treated as the first thread and child thread is treated as the second thread. So now we will see the flow. Now on the first thread, first we will see the flow. I will explain like this. First, whenever you execute this program, JVM will invoke the main method first. Okay. After that, Inside the main method, we are creating the object for one more thread class. After that, I am writing b dot start. These are normal statements only. You know, in multi-threading, this is must. So after this statement b dot start, we have two threads: main thread first thread and child thread the second thread. Next, whenever this synchronized block is invoked, what is the output first? Main thread calling wait method. This is the output. So main thread is calling wait method. Okay, here numbering numbers are there. Okay, as per that you can understand the sequence. And now main thread is calling the wait method output. Next, after that, what I have written b dot wait. B dot wait means what will happen is the first thread will go to the waiting state and releases the lock, and it immediately releases the lock. So when you write b dot wait, here the first thread is going to the waiting state after releasing the lock. Okay, whenever it releases the lock, from that the flow goes to this second thread. Now the second thread acquires the lock and it will execute the run method and this block. So what is the flow now? Whenever the second thread acquires the lock of the object, then the second thread completes its execution. What is the role of the second thread inside the synchronized of this? Now this is child thread starts calculation. So it total is 0. No, initially in the child thread I have taken total is equal to 0. So here it will calculate total is equal to total plus I. Total is 0, 0 plus 0 like that. Next 0 plus 1, 0 plus 1 like that. It will find the total using the for loop. Next after that system dot out dot println child thread. It completes its this role. No, means its execution. No, means child thread starts calculation and it completes its calculation. After that, I have written one more statement to understand the concept. Child thread is giving notification call using this dot notify. Now, sir, whenever it invokes notify method, the second thread means the second thread is giving information to the first thread saying that I have released the lock of this object. You can continue your execution, because the first thread is in the waiting state. No, so whenever the first thread got the notification from the second thread, immediately from this again we will go back and the first thread will continue its execution. Means the first thread from the waiting state, it will go to the blocked state. Again, after getting the lock, again from the blocked state, it will go to the ready state. Again, from the ready state, it will go to the running state. So whenever it goes to the running state, it will complete the remaining part. Okay, what is the remaining part? Main thread got notification, means it acquires the lock of that object. Next, it will print b dot total. B is the object of that thread. No, so b dot total means it is printing the value. So if you see the output, already numbers are there. No, you can easily understand the flow. This is the first main thread calling wait method, means main thread will go to the waiting state. After that, child thread acquires the lock, because this is it is releasing the lock now when it goes to the waiting state. So now the child thread acquires the lock and it will start calculation. Whenever it completes its calculation, child thread gives the notification call to the first thread. Whenever the main thread got the notification, then it acquires the lock of that object and it will enter into the running state through ready state. After that, it will print the value of the total. This is the output. Okay, now here you may get one doubt. What is the difference between notify or and notify all methods? So we can use notify method to give the notification for only one thread, because any number of threads can be in the waiting state. No, but it is giving notification to only one thread. But if multiple threads are in the waiting for notification, then which thread will give? See here, notify all means all the threads which are in the waiting state will get the notification. But which thread will get the chance, we can't expect exactly. It is Java dependent. Notify means it is giving the second thread is giving notification to only one thread which is in the waiting state. But notify all means second thread, when the second thread uses notify all means it is giving notification to all the threads which are in the waiting state. But when it is giving notification to multiple threads which are in the waiting state, no, but which thread will get the chance, we can't expect exactly. This is JVM dependent. But among all the waiting threads, only one thread will get chance for execution. Remaining threads has to wait until further notification. So this is the difference between notify and notifier. So this is one program on inter-thread communication. In another material, we can see one more program on inter-thread communication. And third program is producer consumer problem. You can see the producer consumer problem in complete reference textbook also. That program is there in the complete reference textbook, producer consumer problem. That is there already, it is there in the lab tasks. Okay, so these are the 3 programs we have on inter-thread communication. You can practice at least one program for the exam. Deadlock also important. So what is the deadlock situation? Deadlock in Java is a part of multi-threading. Deadlock can occur in a situation when a thread is waiting for an object lock that is acquired by another thread, and the second thread is waiting for an object lock that is acquired by the first thread. See, okay. Since both threads are waiting for each other to release the lock, the condition is called deadlock. So one program is there on the deadlock in the previous material. Okay, if you complete these 2 materials, then you can cover all the concepts. At least try to learn one program on deadlock also. This is inter-thread communication. Only in inter-thread communication we use wait, notify all methods. Here also you can see. Next, using this diagram, you can understand the process of inter-thread communication. Next year, one more program is there on inter-thread communication. We try to practice this one. We can easily understand here. Here, this is only we can use wait, notify, and notify all methods in the synchronized blocks or methods. No, already one program I explained. No, there I have used synchronized blocks to write the wait and notify methods. But in this program, we can see we are writing. You see wait method. No, we are using the wait method inside synchronized method. So withdraw is a synchronized method. It is not a block. That's why try to practice these 2 programs. This program is inside the synchronized methods. We are using wait and notify methods. But whereas in the first program, we have used synchronized blocks to invoke wait and notify methods. That is the one more difference. Okay. Now here this program is very interesting. Class customer int amount is equal to 10,000. This is synchronized withdraw. Withdraw means going to withdraw. Next, if this dot amount less than amount, already explained this concept in the last class. This dot amount means this instance variable value, and amount means this local variable value. Already explained in the last class this keyword. Okay, when both instance variable, the amount is called instance variable and this is called local variable. No, when instance variable and local variable are having the same names, how to differentiate these 2 is local. This is inside the withdraw method. We are using this amount now. That's why this method will give priority to its own variable, that is local variable. That's why I have to use this keyword to access this instance variable. That's why this dot amount is less than amount. Okay, here system dot out. Here see in the one more difference you can identify between the previous program and this program. In the previous program, wait method, that main method is using throws interrupted exception. No, means declares. But here this withdraw method is the calling method of this wait method. So here the calling method must either handle the interrupted exception or declare the interrupted exception. In the previous program, main method declares the interrupted exception. But here this withdraw method is the calling method of wait method, which is handling that exception. So put the wait method in the try block and write the matching catch block. Matching catch block means here we can write, there are 2 ways we can write the matching catch block, that they are either we can write interrupted exception here or we can write exception, because exception is the superclass of all classes. Okay, try to understand this withdraw. And I have written one more synchronized method, deposit. So in the previous program, I have used two blocks, synchronized blocks. In this program, I am using two methods, synchronized withdraw and synchronized deposit. Next, this is the second method. Inside this is second thread. Okay, inside this one, I am writing notify. Okay. So inside the second thread, I am writing notify. Inside the first thread, I am writing wait. Same concept. Next, this is another way of creating or invoking a new thread or creating a new thread. Here, new thread. I have two threads. New thread. Okay, here you can write like this also. I am instead of writing separate class for this my thread 1 and my thread 2, I am using the same one with this syntax. So new thread public void run c dot withdraw. I have created an object for customer class. You know customer class, no? This is the customer class. Inside the customer class, I have written two methods. Okay, synchronized withdraw. Customer class is normal class. It is not thread because it is not extending either thread or not implementing runnable interface. So it is like normal class. Okay. So inside the customer class, I have written two methods. Okay, that is synchronized withdraw method and synchronized deposit method. So how do we access the withdraw method and deposit method of this customer class? By creating object for that class only. That's why inside the main method of this class, I have created the object for customer class. That's why customer C is equal to new customer. Now this is the first thread I am invoking. This is the second thread I am. Okay, with the start method. So first thread is inside the first thread. I have written C dot withdraw. Inside the second thread, I have inside the invoking inside the overriding run method, I have written C dot deposit. See, inside the overriding run method of the first thread, I have written C dot withdraw, and inside the overriding run method of the second thread, I have written I am invoking deposit method of the customer class. Understand? C dot withdraw, C dot. Now shall we treat this as the first thread and this is the second thread. Shall we see the flow? This is first thread. Inside the first thread, inside the overriding run method, I am invoking withdraw method with 15,000. Okay, now shall we start? We will start from this. First JVM invokes the main method and one object is created for customer class. Next, whenever you write t dot start, one new thread is created. Again, whenever you write t dot start, one more new thread is created. So here between these two threads, I am explaining inter-thread communication concept. Okay. Now we will see the flow. Okay. Now first thread is this one. So C dot withdraw of 15,000. So it will invoke the withdraw method of the customer class. So this is the withdraw method of the customer class. So with how much amount we are invoking the withdraw method? 15,000. So it will go to this withdraw method and the amount is holding 15,000. Okay. Next, system.out.println going to withdraw. Okay. Next, if this dot amount is less than amount, this dot amount is this one, no? 10,000 is less than means this is 15,000. No, I want to withdraw 15,000. So, but in the bank, okay, in my account I have only 10,000. So if 10,000 is less than 15,000, can you withdraw? No. That's why system.out.println less balance waiting for deposit. In my account I have only 10,000, but I want to withdraw 15,000. You can't withdraw, no? That's why it is giving like this, less balance waiting for deposit. So in the output, what is the first statement? Going to withdraw. Next, less balance waiting for deposit. Okay. After that wait. We are invoking wait method on the first thread. Means the first thread has to wait. Means the first thread will go to the waiting state. When the first thread will goes to the waiting state, means it will release the lock of this object. Lock on this object. Okay. The first thread releases the lock of the object. Okay. Lock of the object means what it will do? From this weight, okay, it will go to this next second thread. So whenever the first thread goes to the waiting state after releasing the lock of that object. Lock of the object means which object lock it acquires the first thread? Customer class object only, no? Then only after acquiring the lock on that customer object. See, again I will explain here. Here we have customer object, means customer class object is there. So inside the this statement is that only, no? Customer C is equal to new customer, means customer class object is there. Inside the customer class object, I have two synchronized methods. One is withdraw and the other one is deposit. Okay, so whenever this first thread wants to access the withdraw method, which is the synchronized method, then the first thread has to acquire the lock of this object. When the first thread acquires the lock of this object, okay, when it is accessing the withdraw, which is the synchronized method of that object, no other thread can access any of the synchronized method of that object. Because inside this customer object, we have two synchronized methods. When the first thread is accessing the synchronized method of this object after acquiring the lock of this object, the second thread cannot access this deposit method unless the first thread releases the lock of that withdraw lock of this object. Already explained synchronized methods concept. When the first thread is accessing the synchronized withdraw method, then the second thread cannot access the synchronized deposit method. Means object lock is nothing but all the synchronized methods are locked. Even though the first thread is accessing withdraw method, which is synchronized method of this object, no other thread can access any other synchronized method of that object. Object lock is nothing but all the synchronized methods are locked. Even though the first thread is accessing only one synchronized method, that is withdraw method, but still all the synchronized methods of that object are locked by the first thread. That's why until it releases, the first thread releases the lock of that object, okay, the second thread cannot access deposit method. Now that's why here inside the first thread I have written wait method. No, so first thread will first will invoke the or will execute withdraw method. Only some part it will execute, that is going to withdraw less balance waiting for deposit. After that, on the first thread we are invoking wait method. Means the first thread will go to the waiting state and it releases the lock of that object. So whenever the first thread releases the lock of that object, and it goes to the waiting state, no, means again the flow comes from that wait method to this second thread. Now second thread acquires the lock of this object. Okay, second thread acquires the lock of the customer class object. So inside that I am invoking deposit method. Now the second thread invokes the deposit method with 10,000. When the second thread invokes the deposit method, means whenever second thread acquires the lock of that object only, it can access the synchronized deposit method. Synchronization means lock is must. Next, now we will see C dot deposit of 10,000. So it will execute this deposit method. Now second thread is executing the deposit method after acquiring the lock of that object. Now what it will print? Going to deposit. Next, this dot amount is equal to this dot amount plus amount, that is 10,000 plus 10,000, which is 20,000. Because here this is 10,000 and this instance variables means this dot amount also 10,000. No, so 10,000 plus 10,000 is 20,000. Okay. Next, system dot out dot println deposit completed. So in my account now I have 20,000. Previously it was 10,000 only, but I have deposited again 10,000. No, so 10,000 plus 10,000, 20,000. Now in my account I have 20,000. After that, system dot out dot println deposit completed. After that, see, this is important, notify. Notify means the second thread is giving notification to the first thread, saying that I have completed my task and I am releasing the lock. Now you can acquire the lock of that object. Now after giving notification, okay, by the second thread using this notify method, what is the flow now? Again the first thread will continue, because till now the first thread is in the waiting state. No, now the first, after acquiring the lock from the second thread after completion of deposit method in using notify method, now the first thread again will acquire the lock of that customer object, and again it will invoke the withdraw, synchronized withdraw method, and it will continue the remaining part of the synchronized withdraw method. See, up to this wait method it completed. No, now after again after getting the lock, okay, of that object, it will continue the remaining part of this one. Now this dot amount is equal to this dot amount minus amount, means 20,000 minus 10,000. So system dot out dot println, okay, with not here amount is 15,000. No, here amount is having 15,000 because we are invoking withdraw method with 15,000. No, that's why this 15,000 is stored in amount. No, so here what is the statement we have written? So after completion of this deposit method, we have 20,000 no in our account. Now here this dot amount is equal to this dot amount minus amount. So 20,000 minus 15,000, that is 5,000. Okay. Now withdraw completed. Okay, so this dot amount is holding 20,000 and amount is 15,000, means 20,000 minus 15,000. Okay, now in my account only 5,000 is available, but anyway I have withdrawn this 15,000. I have withdrawn 15,000 because 20,000 is there in my account now, so I can easily withdraw 15,000. So I have withdrawn 15,000. So that's why withdraw completed. So this is real-time application. Now what is the output? So in between the first thread is going to the waiting state. Okay, that is going to first thread, going to withdraw. This is first thread going to withdraw. Next, less balance waiting for deposit. These two statements are by the first thread. Next, second thread going to deposit completed. These two statements are by the second thread. Next, after that again first thread. So withdraw completed. So these two statements are by the first thread. Again after executing these two statements, it will go to the waiting state after releasing the lock of that object. Now the second thread got the lock of that object and it will execute the deposit method. So after executing the deposit method by the second thread completely, it will release the lock of that object. At that time again the first thread acquires the lock of that object and it will complete the remaining part of the withdraw method. That's why here you can understand these two are by the first thread. After that it will go to the waiting state and second thread will complete its execution and it will give notification to the first thread. Okay, whenever the first thread receives the notification from the whenever the first thread received the notification from the second thread, again it will complete the remaining part of withdraw method. Here you can understand first thread these two statements, again second thread these two statements, again first thread this statement. So this program also very important on inter-thread communication. So now you can read or you can see three programs on inter-thread communication. Okay, in the first program I explained with respect to synchronized blocks, and in the second program I explained with two synchronized methods, withdraw and deposit. Next, producer consumer problem, third application, which is there in the book, this one, complete reference textbook. Okay, so with this inter-thread communication is completed. Next class we will see daemon threads and thread group, and one more is static keyword, static methods I will explain. So tomorrow is the last class.